For the last 70 years, astrophysicists have theorized the existence of kugelblitze black holes caused by extremely high concentrations of light. They suggested these special black holes could be linked to astronomical events like dark matter and even proposed as power sources for hypothetical spaceship engines in the distant future. However, new theoretical physics research by a team from the University of Waterloo and Universidad Complutense de Madrid shows that kugelblitzes are impossible in our current universe. Their research, titled No Black Holes from Light, was published on the arXiv preprint server and will appear in physical review letters. Eduardo Martin Martinez, a professor of applied mathematics and mathematical physics and a member of the Perimeter Institute for Theoretical Physics, explained, the most commonly known black holes arise from the collapse of ordinary matter of immense density under its own gravity, because in Einstein's general relativity theory, any form of energy that warps spacetime, such as the massive energy concentration in the form of light, could also lead to a similar collapse. However, this prediction was made without considering quantum effects. The team developed a mathematical model accounting for quantum effects, showing that the light concentration required to create kugelblitzes would be tens of times greater than observed in quasars, the brightest objects in our universe. José Paulo Gomes, a PhD, candidate in applied mathematics and quantum information, noted, long before reaching such light intensity, specific quantum effects would first emerge. This intense light concentration would lead to the spontaneous creation of particles like electron-positron pairs, which would rapidly disperse from the region. While testing such conditions on Earth with current technology is impossible, the team can be confident in their predictions because they rely on the same mathematical and scientific principles powering positron emission tomography PET scans. One way to understand this phenomenon is to consider matter and antimatter annihilation, as seen in PET scans. Martin Martinez explained that electrons and their antiparticles positrons can annihilate each other, breaking down into pairs of photons or light particles. Our results are a consequence of the phenomenon called vacuum polarization and the Schwinger effect. Although it's challenging to explain these concepts in a few words, a useful way to think about this is, the creation of black holes from light is, in many ways, the opposite of the matter-antimatter annihilation observed in PET scans. When there's a high concentration of photons, they can break down into electron-positron pairs. These pairs quickly disperse, carrying energy away and preventing gravitational collapse. While the impossibility of kugelblitzes may be disappointing for astrophysicists, this discovery represents a significant achievement in fundamental physics research, made possible by the partnership between the Perimeter Institute and the Institute for Quantum Computing at Waterloo. Paulo Gomes added, even though these discoveries don't have known applications right now, we are laying the groundwork for our descendants' technological innovations. The science behind PET scanning machines was once purely theoretical, and now every hospital has one.